Hi and Assalamualaikum everyone. Today I'm Nadir Asfar. Will be introducing all my amazing teammates. So the first one is Hasnul Adam. The second one is Muhammad Aiman. The third one is Aiminat Lim.
Welcome to Differentiation with Group 4. What is differentiation? Differentiation is the process of finding the derivative of a function which represents the rate of the change of the function with respect to a variable. Technique of differentiation. The S3 product rule to get the differentiation of product function, Quotient rule to get the differentiation for a fractional function, chain rule to get the differentiation for a composite function.
Next is the problem statement. For the question number 1, we will define differentiation. And for the question number 2, we will differentiate the following. And for the third question, we will be differentiate using implicit differentiation. And for the last question, we will be differentiate the question that was given.
Problem solution for question 1 will be differentiation or derivative is simply a measure of the instantaneous rate of change. It is a concept of real variable that measure the sensitivity to change the value of a function or output with respect to the change in its argument input. It is used to measure the rate of change of a function y equal to fx with respect to its variable x. The application for differentiation will be related rates, analysis of a function, apply maximum and minimum problems, and mean value theorems. Now we'll be moving to question 2. Differentiating hx equal to ln x power of 2 over 2 exponent power of 4x. Step 1, we will be using the quotient rule. The numerator will be u and the denominator will be v. So, numerator will be ln x power of 2, the v will be 2 exponent power of 4x. So, u prime will be the differentiate of the ln x power of 2 and the v prime will be the differentiate of 2 exponent power of 4x. So, step 2 will be substitute the value into the formula. So this is what we get after we substitute the value into the formula. And now step 3, we multiply the numerator because that is the x, because that is a fraction that we need to remove. So we multiply with x and we got the 4 exponent of 4x and the rest. So question 2, so for the step 4, write the final derivative, and that is this is the final derivative. Alright, thank you.
So for question 2, we'll be differentiating y equals to x to the power of 5 cosine 9 minus x to the power of 2. So for step 1, we'll be using the product rule. So as you can see, this is the formula for the product rule. So we'll be substituting the equation right here into this formula. So u is equal to x to the power of 5. V is equal to cosine 9 minus x to the power of 2. Meanwhile, u prime is the differentiation of x to the power of 5. Meanwhile, v is the differentiation form of a cos 9 minus x to the power of 2, which is 2x sine 9 minus x to the power of 2. So for step 2, we will be inserting all the formula in here to this formula. So as you can see in the screen, this is what you get when you put in all the values into the formula. So for step 3, or the final step, we'll be simplifying this equation. So for simplifying, we'll be expanding the equation. So x to the power of 5 will be multiplied with 2x sine 9 minus x to the power of 2. Meanwhile, x to the power 5x to the power of 4 will be multiplied with cos sine 9 minus x to the power of 2. And then you will get this final answer as shown in the screen.
For the next question number 3, we will be using implicit differentiation to differentiate the question. So for the first step, we will be differentiate left hand side and the right hand side. So I will be differentiate the left hand side first. So for the xy cube, I will be using product rule as shown in the screen, and we got the answer here. So and next we will be differentiate exponent y using exponential function. as shown also on the screen, and differentiate ln x that equal to 1 over x as also shown on the screen on how to do it. So, and then we've got the answer here for the differentiation of the left hand side. And next, for the right hand side, we will be differentiate 7x that equal to 7 using algebraic function, and then differentiate tangent square for y using chain rule and trigonometric function using here as shown on the screen, and we've got the answer. And then on the right hand side we differentiate, we've got the answer here. And then step 2 will be putting everything together back, left hand side and right hand side they was differentiated. And then step 3 will be the solve for the dy over dx. We will bring the dy dx factor on the left hand side and the non-factor on the right hand side, and then we factor out it, and then we multiply both sides with x to make the denominator gone, and then we calculate it and bring the factor on the right hand side. That means we have to divide it, and then we've got the answer as shown on the screen. That's all.
Next, we will continue with question 4. So the question asks us to use differential to estimate these numbers and give our answer to 3 decimal places. To solve this question, we must go through these steps. The first step is to identify x and fx. The second step is identify x naught and f naught, differentiate fx, and then find f prime x naught, and next we use this formula to find the estimation. So step 1, we will identify x and fx. So we can conclude that x is equal to 8.01 and fx is equal to x squared plus 2 over x to the power of 3. Step 2, we will identify x naught and find f naught. To find x naught, we use the first term and we evaluate, and I evaluate this term, and it becomes 64.1601, and we round it up, becomes 64. 64 is also equal to 8 to the power of 2. So we can conclude that x naught is 8. Step 2, identify x naught and find f naught. So this is the function of fx. We just substitute the value of x naught inside this equation, this function. We will get 64.0039. Step 3, we will differentiate fx. To differentiate fx, first we must transform this to a simpler form so that we can differentiate easier. So I transform it, become 2x to the power of negative 3. And after differentiating, the last result we got is 2x minus 6 over x to the power of 4. Step 4, find f prime x naught. So we just substitute the differentiated fx and we substitute it with the value of x naught. So after substituting, we got 15.9985. So the last step, we use this value that we got, and we just use this formula and substitute one by one. And after calculating, we can conclude that fx, the estimation of fx is 64.164 in 3 decimal point. That's it from me. Thank you.
So in conclusion, we can conclude, therefore, identifying the right formula and using the correct techniques to differentiate will lead to precise and correct answer. Thank you and thanks for watching. Bye.